Hello students. Hello and welcome to this video. Let me check if the video is recording. Yep. Okay. So in this video we will solve question number 141 to 150 of determinants. Apologies for the delay in the video today. So all successive videos will also be delayed. So from tomorrow onwards I'll try to be a bit early. So question 141 says that, okay, I need to repeat the ritual. The link to download the PDFs will be in description. At the end, I will show you how you can download videos from my website and maintain an updated copy. Also, I'll show you my question and answer website where you can come and ask and answer questions. So question 141 says that solve the equation u plus a square x w prime plus abx v prime plus acx w prime plus abx v plus b square x u prime plus bcx v prime plus acx u prime plus bcx w plus c square x is equal to 0, expressing the result by means of determinants. So what we do is we perform C2 is equal to AC2 minus BC1 and C3 is equal to AC3 minus CC1. So we have to put 1 upon a square outside the determinant because we are multiplying column 2 and column 3 with a. Upon doing this, column 2 will become AW prime minus BU, AV minus BW prime, AU prime minus BU prime, AV prime, and third column becomes AV prime minus CU, AU prime minus CW prime, AW minus CU prime. So the idea is to get rid of x from the second and third column, which we have done. And a square can be thrown to the 0 right hand side. We don't care about a square. Now once we have this, we can split this determinant on the first column in such a way that first column of one of the parts will be u, w prime and b prime, that is this one, and the second one will have a square ab ac. So x we take out from this, so this plus x into this will be equal to 0. So x will be minus of this determinant divided by the other part of the split determinant. Question 142 says that if f of a comma b is equal to f of b minus f of a upon b minus a, and f of a comma b comma c is equal to f of b comma c minus f of a comma b upon c minus a, then we have to show that f of a comma b comma c is equal to f of a, f of b, f of c, 1 1 1 abc divided by 1 1 1 abc a square b square c square. So here we take f abc and we perform c1 is equal to c1 minus c2 and c2 is equal to c2 minus c3, and we divide by k as well. K, I don't know where k is coming from. Okay, so the value of the determinant in denominator is a minus b times b minus c times c minus a. So this determinant is a minus b minus c, c minus a is equal to k. That's what we have learned. So that's where k is coming from. Now we look at this determinant and we evaluate along this one, we get minus b minus c f of a minus b minus a minus b f of b minus f of c divided by k. Whole is divided by k. Okay. Now once we have that, we take out a minus b and b minus c, and we are left with f of a minus f of b upon a minus b minus f of b minus f of c upon b minus c divided by k. So this becomes a minus b times b minus c times f of a minus b minus f of b minus c divided by k. So if we divide by k, that is a minus b times b minus c times c minus a, we take this and we have a minus b times b minus c times c minus a, f of b minus c minus f of a minus a comma b upon c minus a which will eventually turn out to be a comma b comma c. I suspect there is something wrong at this step, right? I don't have pen and paper to evaluate it, but if you perform the calculation that way, eventually you will get at f of a comma b comma c. So it's a very easy question, nothing complicated. Excuse me. Question 143 says that if A, B, C are the angles of a triangle ABC, then prove that e to the power 2ia, e to the power minus ic, e to the power minus ib, e to the power minus ic, e to the power 2ib, e to the power minus ia, e to the power minus ib, e to the power minus ia, e to the power 2ic is purely real. Here I is iota, that is square root of minus 1, and a plus b plus c would be 180 degree or 2 pi. So because ABC are angles of a triangle, so we have a plus b plus c, not 2 pi, pi radian. My mistake. So we have this, and we know that e to the power I pi is equal to cos pi plus I sin pi is equal to minus 1, or this is Euler's equation, famous one. So what we do is we take e to the power ia, e to the power ib, e to the power ic common from row 1, row 2 and row 3. So outside we will have e to the power ia plus b plus c, that is pi, that is minus 1. So this will be minus 1 eventually. And inside we will have e to the power ia, e to the power minus I a plus c, e to the power minus I a plus b, and so on we will have. So this a plus c will be pi minus b. So it will become e to the power ib minus e to the power ib minus e to the power ic, and so on. So you will see that first column is e to the power ia, second is e to the power ib, third is e to the power ic. So once you take e to the power ia, e to the power ib, e to the power ic common, again minus will be the result, and minus minus will be plus, and the determinant will be minus 4, which is purely real. Question 144 says that if ABC are the angles of a triangle ABC such that A greater than equal to B greater than equal to C, find the minimum value of delta, where delta is equal to sin square A cos square A, sin square B sin B cos square B, sin square C cos square C. Also show that delta is equal to 1 upon 4 sin 2A minus 2B plus sin 2B minus 2C plus sin 2C minus 2A. So we have this determinant, we perform column 1 is equal to column 1 plus column 2, column 3, and we get 1 1 1 in the first column. Then we perform the usual R3 minus R1 and R2 is equal to R2 minus R1. We will get 2 zeros and then we expand. We will get sin A minus B times sin B minus C times sin C minus A, which would be greater than equal to 0. And then you can go on and do the second part, which should be fairly easy if you know trigonometry. And if you can't solve the second part, let me know in the comments and I'll provide the full solution. Question 145 says that evaluate a square a cos nx cos n plus 1x cos n plus 2x sin nx sin n plus 1x sin n plus 2x. So since we have 3 ones and not 3 ones, a square and a, so what we do is we let me see, we take c1 is equal to c1 minus ac2 and c2 is equal to c2 minus ac3. So we are left with 2 zeros here, and the second row becomes cos nx minus a cos n plus 1x cos n plus 1x minus a cos n plus 2x cos n plus 2x, and third row would be sin nx a sin n plus 1x sin n plus 1x minus a sin n plus 2x sin n plus 2x. So we evaluate against this one, okay, and we will have sin n plus 1x cos nx, that is the multiplication of these two, and then minus multiplication of these two, which is here. And upon evaluation, you will end up arriving at a square minus 2a cos x plus 1 sin x. Let me know if there is anything wrong in the calculation, and thus we will have our delta. Question 160 says that if 0 less than x less than pi by 2, then there should be n here, missing n. Find the values of x for which 1 plus sin square x cos square x 4 sin 2x, sin square x 1 plus cos square x 4 sin 2x, sin square x cos square x 1 plus 4 sin 2x has the maximum value. So here we perform column 1 is equal to column 1 plus column 2. We get 2 to 1 cos square x, and other two columns remain same basically. And once we have that, we perform R2 is equal to R1 is equal to R1 minus R2. We get two zeros, and then we expand along minus 1. We get at 2 minus 4 sin 2x. So this expression will have maximum value between 0 and pi by 2 when x is equal to pi by 4. Because why pi by 4 is because we want to, in order to maximize the value, right? This should be minimum. 2x should be minimum, right? Maximum value. Okay, this may be wrong here. So this should be minimum here for this. Okay, and sin 2x will be minimum between 0 and pi by 2. It won't be maximum, it will be minimum at this value, that is x is equal to pi by 4. So if you have sin 2x here, sin x is maximum at pi by 2. So if sin x is maximum, this will be minimum here. And sin x will be minimum between this range, that is 2x, x should be between pi by 2 and pi. So x should be pi by 2 here. Okay, if x is pi by 2, 2x would be pi, and then it would become minus 1, and minus 1 times minus 4 would be plus 4. So you can adjust it. Okay, I don't think this is correct answer. Question 147 says that if A, B, C are the angles of a triangle, show that minus 1 cos C cos B, cos C minus 1 cos A cos B cos A cos 1 is equal to 0. So we expand the determinant, we get delta is equal to minus 1 plus 2 cos A cos B cos C plus cos square A plus cos square B plus cos square C. Now we consider the expression 2 cos square A plus cos square B plus cos square C, that is equal to 1 plus cos 2A plus 1 plus cos 2B plus 1 plus cos 2C. This requires trigonometric understanding, and once we have that, we evaluate it. It is equal to 2 plus 2 times cos A plus B cos A minus B plus 2 cos square C. Once we have that, we can write that as 2 plus 2 cos pi minus C cos A minus B plus 2 cos square C. So pi minus C will be minus cos C. So this is equal to 2 minus 2 cos C cos A minus B minus cos C. And upon evaluating, we get this is equal to 2 minus 4 cos A cos B cos C. And thus our delta is equal to 0. Question 148 says that if ABC are the angles of an isosceles triangle, evaluate 1, 1, 1, 1 plus sin A, 1 plus sin B, 1 plus sin C, sin A plus sin square A, sin B plus sin square B, sin C plus sin square C. Now ABC are angles of an isosceles triangle, so without loss of generality we can assume A and B are equal. Now if A and B are equal, column 1 and column 2 will become same, and the determinant will be equal to 0. Question 149 says that for positive numbers x, y, z not equal to 1, show that the numeric value of the determinant 1 log of y with base x, log of z with base x, log of x with base y, 1 log z with base y, log of x with base z, log of y with base z, 1 is equal to 0. So what we do here is we represent the logs in terms of fraction. It becomes 1 log y upon log x, log z upon log x upon log y, 1 log z upon log y, log x over log z, log y over log z, and 1. Now what we do is we take log x, 1 upon log x common from row 1, 1 upon log y common from row 2, and 1 upon log z from row 3. So this will become log x, first row will become log x, log y, log z, second row will become log x, log y, log z, and third row will also become log x, log y, log z. Now all three rows are identical, determinant will be equal to 0. Question 150 says that if A, B, C are greater than 0 and x, y, z belong to the set of real numbers, then we have to show without expanding that A raised to the power x plus A raised to the power minus x whole square, A raised to the power x minus A raised to the power minus x whole square 1, and then B and C with powers of y and z similar 1, 1 is equal to 0. Now, what we do here is we expand the binomial terms here. So we get a to the power 2x plus a to the power minus 2x plus 2, and here we get minus 2. So plus 2 and minus 2. Once we have that, what we do is we do column 1 is equal to column 1 minus 2 column 3, and column 2 is equal to column 2 plus 2 column 3. So the 2 plus 2 and minus 2 will be eliminated. Once they are eliminated, two columns becomes identical and the determinants becomes 0. So with this, we come to the end of question 150. I'm sorry for this question 146. It is not quite correct answer. This should be pi by 2. But x should be less than pi by 2, so it should tend to pi by 2 actually. So this pi by 4 is true. This answer is true if we want to find the minimum value. Okay. So it may be the case that I made a mistake of having maximum value instead of minimum value. This answer is true for minimum value, not for maximum value. So now I'll show you my website. Let me launch the browser. We go to gustavacco.org. You can download the PDF from second, third, and fourth link for algebra, trigonometry, and coordinate geometry. Note that when you will download the PDF, it won't have date. So you need to edit the date manually. That is this date, and after 15 or 30 days you should come and check again whether the date has changed, and if the date has changed, then you can download again and add that date. Now I cannot put the date in the PDF because if I do that, then the existing links everywhere will become invalid. Also for coordinate geometry, the HTML format is going to be removed. We will have only PDF. Now about the question and answer website, you can click its link or come to kunjika.gustavacco.org. You can make a login here. We have tags of algebra, calculus, coordinate geometry, geometry, probability, trigonometry, and mathematics for asking questions. So let's build a community and let's ask and answer questions here, because YouTube comment box is not really suitable for mathematical content. So with this, I will take my leave and we will meet again tomorrow with 10 more problems of determinants. And I hope that you have learned something useful in this video. And I'll see you tomorrow with 10 more problems. Till then, stay curious, keep learning, and most importantly, enjoy.